guys, we're getting into the 9.2 section, a couple key concepts. We know our quadratic functions in standard form, y equals x squared plus bx plus c. We talked yesterday, a is gives us, that's our leading coefficient there. It tells us whether we open up or down. Positive, it opens up. Negative, it opens down. The closer it gets to 0, the wider the parabola gets. The bigger it is, or the further it gets from 0, the narrower it gets because it grows faster. And then we're going to start talking about b and c a little bit today. B, the value in front of x, will impact the line of symmetry, which is one of our key concepts today. And then c is our y-intercept. Alright, so the first key concept going forward is when we graph a parabola, we know that it's going to end up having that U shape. So somewhere we're going to have a max or a min point, and it's going to come down into that U shape. And what we want to find is we want to find that vertex point and the line of symmetry, which is an imaginary line that cuts our parabola in half. And once we find that, we can end up constructing the rest of the parabola pretty easily. Okay, so the first key concept then is how do we find that, that vertex or line of symmetry? Let's say we're given a quadratic that looks like y equals negative 2x squared plus 8x minus 3. And you're asked to either graph it or find the vertex or axis of symmetry. And what we really want to do is first we want to find the axis of symmetry, that vertical line that's going to cut our parabola in half. And it's pretty simple. To find the axis of symmetry, AOS, it's x is going to equal, because remember a vertical line is x equals the opposite of b over 2a. It really is that simple. And what I'll do is in the second video, I'm going to probably put a couple of these together for you just so I can show you how these get graphed by constructing a table of values. But if I'm trying to find the axis of symmetry, okay, I know a in this case equals negative 2, b is 8, and c is negative 3. So the axis of symmetry is going to be the opposite of 8 over 2 times a, which is negative 4. So I'm going to get positive 2. So this is going to equal 2, which means where x is 2, I'm going to have a vertical line that's going to come down and cut my parabola in half. So that gets me started. Now the second thing I want to do is I want to find the vertex. And pretty much I know it's going to be on this line because that's going to cut it in half. So step 2, find vertex. And we found half of it already. This right here is the x value, x equals 2. That's the x value of the vertex. We just got to take this guy, 2, and plug it back in for x, and that'll tell us our y value. So then step 2 is let's take this value to find the vertex, plug 2 in. So y is going to equal negative 2. And yesterday I showed you that when you use it in these quadratics, put parentheses around what you're plugging in and the squared on the outside, because if that's negative, that's going to affect what you're doing. Don't put the squared on the inside, put it on the outside. Plus 8 times 2 minus 3. And the calculator does this work for you. Hey, Gaddy. The calculator does this work for you. Or you can just do it mentally. 2 times 2 is 4, times negative 2 will be negative 8 plus 16 minus 3. That's going to get me negative 11 plus 16 ends up getting me 5, I believe, right? So y is going to equal 5. And there's my vertex then. The vertex is going to be the ordered pair 2, 5. So now I go over to 2, up 1, 2, 3, 4, 5. I plot that point. Okay, so that's how I find the axis of symmetry. That's how I find the vertex. Now if you were asked to graph this, at that point then I would just create a table of values and put a couple of ordered pairs in. Put a couple values in for x to find y. And what I try to choose is just values that are close to here. So like I want to pick maybe 1. If I pick too far away, it's going to go off my paper. So let's put 1 in and do the math. And then maybe I'll put 0 in. 0 is a nice number. As a matter of fact, we already know what 0 is because if you remember earlier, that negative 3 is my y-intercept. So it's going to be at 1, 2, 3 down here. But I'll plug 0 in. And then I'll show you how symmetry will help us figure out the rest of this. So let's first put 1 in. If I put 1 into here, I'm going to end up getting 1 squared is 1. So it's negative 2 plus 8 minus 3. Negative 2 plus 8 is 5. 5 minus 3 is 2. So when I put 1 in, I get 2. When I put 0 in, I should get 3. 0 plus 0 minus 3 is actually get negative 3. 0, 1, 2, 3. Now, I want to find a couple points on this side and then a few points on the other. And now this is where the axis of symmetry comes in. If I'm 1 away here, I'm just 1 away on the other side of that axis of symmetry. So if I plugged in 1, 2, 3, I should get the output of 2 as well. Since I'm 2 away here, I'm going to be 2 away on the other side of that axis of symmetry. And again, that's enough points right there. It's plenty. And I can just go ahead and kind of sketch that U shape. Notice it's just like we did before when we were talking about our exponential growth and decay, how it kind of curved. This is kind of U-shaped. It's not straight edged from side to side. A couple things to mention. A is negative. It's opening downward. That we see that. Negative 3 is our y-intercept. Our axis of symmetry we found first. It's just the opposite of b over 2a. So I label a, b, and c. The opposite of b is negative 8 over 2 times a. It would be negative 4, which is 2. I plug 2 in for x to do the math to find my vertex. Plot that point, find a couple of ordered pairs, and create my parabola. All right, I'll put another video together. I know we still have to do the vertical motion model I want to show you. And again, I'll probably put a couple of examples together and show you how to get started on your 9.2 packet. All right? All right, see you in a bit.